Now quantum numbers. Quantum numbers, it explains the location of an electron or position of an electron in an atom. Now there are actually Schrodinger wave equation. It explains three quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number. Okay, but Schrodinger wave equation does not explain the spin quantum number. Okay, now one by one we'll study the quantum numbers. These are the very important question. Okay, now first one. What is the principal quantum number? Okay, principal quantum number. It is represented as n. It gives the information about main shell. Okay, main shell, or I can call it as orbit. It gives the information about main shell or orbit. Suppose this is a nucleus. Now electrons revolves around the nucleus like this. Okay, these circles are called as shell or orbit. So n is equal to 1, n is equal to 2, n is equal to 3. If I draw one more circle, then it is called as n is equal to 4. So principal quantum number, it gives the information about a main shell or orbit in which electron belongs. So n value, it becomes 1, 2, 3, 4, etc. Infinite value. N never be 0. N never be 0. It gives the n is equal to positive integers. N is equal to positive integers. Okay, and it also gives information about the size. Okay, size of orbital. Size of orbital. It also gives the information about size of orbital. If only one shell is present, it is a smaller atom. If two shells are present, it is a little bigger. Okay, so it is also gives the information about the size of orbital, and it also gives about the information about the energy of the shell. Energy of the shell. That means if electron is present in the first shell, then it has a lesser energy. If electron present in the third shell, it has a higher energy. That means as shells are closer to the nucleus, it has a lesser energy. As shells are far away from the nucleus, then it has a higher energy. Okay, so I will repeat it again. Principal quantum number, it represents as a n. It gives the information about main shell or orbit in which electron belongs. That is n value, it becomes 1, 2, 3, 4, infinity. N never be a 0, It is only a positive integers. Okay, it also gives the information about size of the orbital and energy of the orbital. That means if a shell, shell is very close to the nucleus, its energy is this shell's energy is very less. If shell is far away from the nucleus, its energy is more. Okay, it is also represented as a K shell, L shell, M shell, N shell, like that. That means first shell it is represented as K, second shell it is represented as L, third shell it is represented as M, like that it will go. So this is about a principal quantum number. Second, that is a azimuthal, or it is also called as a angular momentum quantum number. Azimuthal quantum number or a angular momentum quantum number. It is represented as a L. It is represented as L. It gives the information about a subshell. Okay, it gives the information about a subshell. Okay, and also it gives the information about the shape of the subshell. Shape of the subshell. So azimuthal quantum number, it gives the information about the subshell in which electron belongs, and also it gives the information about the shape of the subshell. That means L value, it starts from 0, 1, 2, 3, okay, n minus 1 up to n minus 1. Now that means now L is, if it is a 0, then it is called as a S subshell. If L is equal to 1, then it is a P subshell. If L is equal to 2, then it is a D subshell. If L is equal to 3, F subshell. Okay. If L is equal to 4, then it is a G subshell. But atom having a G subshell, it is not discovered. It is not discovered. Only S, P, D, F, it is a discovered. Okay. So I will repeat. Azimuthal quantum number or angular momentum quantum number, it is represented as L. Okay, letter L. It gives the information about subshell. Okay, and also it gives the information about the shape of the subshell. What are the values of L? L can be 0, 1, 2, 3 up to n minus 1. Okay, so if L is equal to 0, then it is a S subshell. If L is equal to 1, it is a P subshell. If L is equal to 2, it is a D subshell. L is equal to 3 means it is a F subshell. L is equal to 4, it is called as a G subshell, but it is an atom having a G subshell, it is not yet discovered. Okay. Now, shapes. What are the shapes? Now here, if it is S subshell, then it is a spherical. I already explained the shape. Okay. Now P means it is a dumbbell shape. D means it is a double dumbbell shape. Okay. F, actually it is a complex shape. It has a complex shape. I will repeat. S means it is nothing but a spherical shape. P means dumbbell shape. D means double dumbbell shape. F is a complex shape. I already explained. Go through that. Okay. Now, what are the values of L based on the N? Here I will write what are the values of L based on N. I already told that L values start from 0, 1, 2, 3 up to n minus 1. Suppose, imagine that if I write n is equal to 1, now L becomes 1 value. What is a 1 value? That is the first value, it is a 0. If n is equal to 2, how many values I should write? 2 values I should write, 0 and 1. So 0, 1. Okay, n is equal to 3 means L, how many values you should write? 3 values you should write, 0, 1, 2. N is equal to 4 means how many values you should write? 0, 1, 2 and 3. 1, 2, 3, 4. 4 values. N is equal to 1 means 0. N is equal to 2 means 0 and 1. 2 values you should write. N is equal to 3 means 0, 1, 2, 3 values you should write. N is equal to 4 means 0, 1, 2, 3, 4 values you should write. So based on that, it is written as a n minus 1 value. Up to n minus 1 value you should write. Now what is the meaning of this? Based on this you can write a subshell also. Now this, it is a, what is a, if it is a 0, n is equal to 0 means what is a subshell? That is yes subshell. What is the n value? You have to write 1. So 1 is a subshell. I hope you understood. I will repeat. L is equal to 0 means what is the subshell? Yes, a subshell. So since n is equal to 1, so it is written as 1 is a subshell. Now here, L is equal to 0 means what is a subshell? This I will erase. L is equal to 0 means what is a subshell? Yes, subshell. Since n is equal to, you have to write 2s. 1 means it is a P subshell. Since it is 2, you have to write 2s. Okay. So, if suppose n is equal to 3. So, how many values you should write? 0, 1, 2. So, 0 means yes subshell. Since n is equal to 3, it is written as 3s. L is equal to 1 means it is P. So since it is 3, n is equal to 3, so 3p you should write. Okay, now here 2 means d sub shell, so it is a 3d. Same way, if n is equal to 4 means how many values I should write? 0, 1, 2, 3. 1, 2, 3, 4 values. Okay, now L is equal to 0 means what is the name of the subshell? S subshell. Since it is 4, n is equal to 4, you should write 4s. 1 means L is equal to 1 means what is the name of subshell? P. Since it is 4, it is 4p. L is equal to 2 means it is D subshell, so it is written as 4D. N is equal to 4 means it is F. Sorry, L is equal to 3 means it is F, so 4F. Okay, I hope you understood the concept. So I will repeat azimuthal quantum number. L is equal to 0, 1, 2, 3. Okay. Now 0 means S subshell, 1 means P subshell, 2 means D subshell, 3 means F subshell. So based on that, if n is equal to 1, what are the values? 0. So 0 means S subshell. So since n is equal to 1 is given, so it is called as a 1s subshell. If n is equal to 2, how many values I should write? L is equal to 0, L is equal to 1. So 2 values. Okay, so L is equal to 0 means S subshell. But which S subshell? Since it is n is equal to 2, it is written as 2s. L is equal to 1 means it is a P subshell. Since n is equal to, you should write 2p. Same way, n is equal to 3 means how many values I should write? 3 values. L is equal to 0, 1, 2. Okay, so 3 values have written 0, 1, 2. 1, 2, 3 values. So 0 means what is the subshell? S subshell. I hope you understood. Since n is equal to 3, what I should write here? 3s. Okay, L is equal to 1 means here it is written, it is fixed, P subshell. Okay, since n is equal to 3, what I should write? It is a 3p. Okay, here n is equal to 2 means what is the subshell? It is a D subshell. So since it is n is equal to 3, here you should write 3D. Okay, I hope you understood the concept. Now, third one, magnetic quantum number. It is represented as M. Okay, it gives an information about a possible orientation of orbital in space. Possible orientation of orbital in space. That means it gives the information about direction of the atomic orbital in space. Okay, orientation of orbital in space. What about principal quantum number? It gives the information about the main shell. How many main shells are present. Azimuthal quantum number, that is represented as L. It gives the information about subshell and shape of the subshell. Magnetic quantum number, it gives the information about direction of the orbital, x-axis or y-axis or z-axis. Okay, how it is orientation of the atomic orbital in space. Now here how it is written, what are the values of m values? It can be written as m is equal to minus L 0 plus L, or how many values are possible? M is equal to 2L plus 1 values are possible. Okay, 2L plus 1 values are possible. Suppose now here, suppose L is equal to 0, then how to write m value? It is written as m is equal to minus 0, 0 plus 0. So this indicates that it is nothing but a 0. Suppose L is equal to 1. How I can write? M is equal to minus 1, 0 plus 1. Suppose L is equal to 2. What is the value I can write for m? Minus 2, minus 1, 0 plus 1, plus 2. If suppose L is equal to 3, then what is the value of M? Minus 3, minus 2, comma minus 1, 0, plus 1, plus 2, comma plus 3. I hope you understood. Okay. Now here 2L plus 1 values. How it is? 2L plus 1 values. I will show you. Okay. Now here suppose this I will take. L is equal to 0. That means M is equal to 0. I will substitute here. Okay. If suppose L is equal to 0 to this concept. So 2 into 0 plus 1. If suppose L is equal to 0. So what is the answer you will get? 1. Okay. So only one value you will get. Same thing. If I take this L is equal to 1. So how many values are possible? 2 into 1 plus 1. So 2 2s are 2 1s are 2 plus 1. So what is the answer you will get? 3 values. M is equal to 3 values are possible. So here 1, 2, 3. So 3 values are possible. Same thing. If suppose if I take this L is equal to 2. So 2 into 2 plus 1. So what is the answer you will get? 2 2s are 4 plus 1. It is a 5. 5 values are possible. Here you can check 5 values are possible. Minus 2, minus 1, 0, plus 1, plus 2. So 5 values are possible. Same thing, you will get same thing for this also. Okay. So M is equal to 2L plus 1. Now this, I already told that it gives the information about the direction. Okay, whether it is in x-axis or y-axis or it is in a z-axis. Electrons are oriented in x-axis or y-axis or z-axis. Okay, so based on that, now here I will write n is equal to 1 means what is the possible value of n? L it is a 0, 1 value. So n becomes it is a 0. Okay, so 0 means it is nothing but s. Okay, now here since n is equal to 1, so 1. That means this 1s means it is nothing but a 1s orbital. Now I am writing as a 1s orbital. Okay, 1s orbital because I introduced m. I introduced the m value, so I am writing as a 1s orbital. 1s orbital means one box like this. So in this I have to accommodate. Now I already told a maximum of 2 electrons I can accommodate. Maximum of only 2 electron I can accommodate in a orbital. Okay. So if suppose n is equal to 2, so what are the values of L? That is 0 and 1. So what is the value of m for this? If L is equal to 0, so m is equal to 0. So what is the orbital you will get? 0 means s. Now since I introduce m, magnetic quantum number, I have to write s orbital. Okay. Now but this is which one? Since it is n is equal to, so here I should write 2s orbital. Now m, what are the values of m here for this? L is equal to 0 means minus 1, 0, plus 1. So how many values are possible? 3 values are possible. Here L is equal to 1 means P. Since m word I introduced, so what you should write? P orbital you should write. Okay, now n is equal to 2 means since it is called as a 2p orbital. Now this, how many directions are there? Based on these values, 3 values are there. That means 3 directions are possible. So this is written as 2px, 2py and 2pz. You already learned how p orbitals are arranged. Lobes are arranged along the x-axis. Okay, like this. Lobes are arranged along the x-axis. Even lobes are arranged along the y-axis. Okay, if lobes are arranged along the z-axis. So this is a px, this is py and this is a pz. Since it is n is equal to, you should write 2px, 2py and 2pz. I hope you understood the concept. Okay, now one more example I will give you so that you can understand more clearly. Okay, so suppose n is equal to 3. What are the L values? L is equal to 0, L is equal to 1, L is equal to 2. Now you have to say, well, now say in your mind what are the m values. Okay, so m is equal to 0 here. So which orbital is possible? S orbital is possible. Which S orbital is possible? Since n is equal to 3, you should write 3s. Now here m is equal to -1, 0, plus 1. 3 values are possible. So based on that, L is equal to 1 means it is a p orbital I will write. Okay, so which p orbital? 3p orbital, because n is equal to 3 is given. Okay, but here this is a 3px, 3py, 3pz, like this you have to consider. That means in p orbital how many box I should write? 3 box I should write. In s orbital only 1 box I will write. Okay, so each box accommodate how many electrons? 2 electrons. Each box accommodate only 2 electrons. So in p orbital how many electrons are present totally? 1, 2, 3, 4, 5, 6. So 6 electrons are present. Same thing here. D, L is equal to 2 means m is equal to -2. Below I will write. Okay, m is equal to -2, -1, 0, +1, +2. Okay, how many values are possible? 1, 2, 3, 4, 5. Okay, now here, so 2 means it is a D. Okay, since it is n is equal to 3, so 3d orbital you should write. 3d, how d orbitals are arranged? It is a double dumbbell. Okay, go back, see the previous video about the shapes of the atomic orbital. Double dumbbell shape, it is arranged between, the lobes are arranged between the x and y. So then it is called as a dxy. Okay, so and then d xz, that means lobes are arranged between x and z. D y z, d x square minus y square, d z square. So how many d orbitals are present? Total 5 d orbitals are present. So for each thing you have to give the values. dxy means this. Okay, any you can select. There is no restriction that -2 you have to give only for dxy. -2 you can consider even dxz also. Okay, so like this. So that means d orbital. Okay, so d orbital. How many box I should draw? D means it is a 5 values you got. So 1, 2, 3, 4, 5. So 5 means each box accommodate how many electrons? 2 electrons. Okay, so d orbital total contains how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons. In p orbital how many electrons? Total 6 electrons. S orbital how many electrons? Total 2 electrons. D orbital how many electrons? It is a 10 electrons. Okay, same thing. F orbital contains 7 boxes. 1, 2, 3, 4, 5, 6, 7. So each accommodate 2 electrons. So how many electrons F orbital contains? Total 14 electrons. Total 14 electrons. I hope you understood the concept. Okay, now next it is a spin quantum number. Okay, now spin quantum number, it is represented as S. It is not a variable of Schrodinger wave equation. Okay, this will not tell us about the atomic orbital. It will not give any information about atomic orbitals. It gives only the direction of the or spin of the electron. Okay, I already told that orbital contains 2 electrons. Each orbital contains 2 electrons or accommodate only 2 electrons. Okay, so electron, it has a 2 direction, clockwise direction and anti-clockwise direction. Clockwise direction and anti-clockwise direction. That means electron, it spins its own axis. Electron usually spins its own axis. Okay, so it rotate either clockwise direction or anti-clockwise direction. Suppose now this is a clockwise direction, and if like this, it is a anti-clockwise direction. Okay, now the value is given that S is equal to plus half and S is equal to minus half. Okay, now I will select plus half for clockwise direction, minus half for anti-clockwise direction. There is no restriction that you have to select clockwise direction value, it is a plus half. Okay, you can also select clockwise direction as a minus half. If clockwise direction is a minus half, then of course anti-clockwise direction is a plus half. Here I considered clockwise direction is a plus half, so of course anti-clockwise direction is a minus half. So spin quantum number, it explains the spin of electron. So here it is represented like this, half headed arrow. That means upper direction, lower direction. Upper direction means clockwise direction, lower direction means it is anti-clockwise direction. Okay, so this is the 4 quantum number. So based on 4 quantum numbers, just I will work out a few problems, few questions, application based questions. Okay, that is first one. How many subshells and orbitals are possible for n is equal to 2? How many subshells and orbitals are possible for n is equal to 2? So n is equal to 2 means what are the values of L? Subshell, it comes under L, azimuthal quantum number. So of course I should write L. So L 0 and 1, 2 values I should write. So it is a subshell. How many subshell? 2 subshells are possible. Since how many it is asked, 2 subshells are possible. Suppose question is asked, name the subshell. Instead of how many, if question is asked, name the subshell and orbitals are possible for n is equal to. So what are the names? It is a S subshell. N is equal to 0 means S subshell. Since n is equal to 2 values given, you have to write 2s. Here L is equal to 1 means P subshell. Okay, since n is equal to 2 is given, so 2p subshell you should write like this. I hope you understood this concept. Okay, now orbital value. Orbitals are asked. So orbital means I have to introduce m, magnetic quantum number. So suppose L is equal to 0 means what is the value of m? M is equal to 0. Since it is orbital, so m is equal to, now L is equal to 1 means what is the m minus 1? 0 plus 1. Okay, now here how many orbitals are possible? 1, 2, 3, 4. Total 4 orbitals are possible. Since it is asked how many orbitals, so you should write 4 orbital. Suppose same thing what I told in the previous case, like name the subshell. Suppose if question is asked as a name the orbital, so how you will write this S orbital, this S orbital, okay, 0, which S, that is a 2s orbital. Here this is a 2p orbital because it is a L is equal to 1, 2p orbital. In deep, how you can write 2p x, 2p y, 2p z for this. I hope you understood. Okay. Now this is a homework for you. How many subshells and orbitals are possible for n is equal to 3? Name the subshells, then orbitals. This is a homework for you through video. Watch the video properly and send it through WhatsApp. Thank you.